Hello, this is our class for Friday, April 3rd. I want to start by talking about an exam. So originally there was an exam scheduled for today. We lost a week when spring break was extended. So I figured the exam would certainly be pushed back a week, and we can't really have a normal exam because, and how would I give it, right? So what I'm planning to do is to give you something that's sort of like an exam, but it's basically going to be a take-home exam, kind of like an extended homework. I'm just going to email it out to everybody and then have you email your answers back to me. I think that's what I plan to do. I might end up putting it on D2L, but I think I'll just send it out and have you fill your answers in a Word document or maybe just in an email, and then have you email it back to me, or I might make a D2L Dropbox. So I'll probably send it out like later next Thursday and give you the whole weekend and make it due like Tuesday or something like that. So that's the timeline I'm planning. Send it out Thursday, April 9th, and then have it due on Tuesday, April 14th. Okay, so send out Thursday, April 9th, due Tuesday, April 14th. So that'll be my plan for the exam. And so that's going to cover from the first exam up until the stuff we did like before today's stuff. So that's the Poisson distribution, Poisson process, inter-arrival time, also known as exponential, and then uniform distribution, normal distribution, and then the start of the stat stuff that we've been doing, the confidence interval and the hypothesis test for one proportion. Okay, so I don't know that you need to study for that because it is a take-home and you have a few days, but you definitely want to be caught up on the material by then if you've managed to fall behind in these first couple weeks since we got locked down. Okay, so for today, we're moving to a new section, 10.2, where we're looking at two proportions. So up until now, we've been doing the stats on one proportion, and we want to know the proportion of our total population that has a certain feature, like total population of people who voted for a certain person, that kind of thing. And we're trying to estimate that using a limited amount of data in our sample. So now there's going to be two proportions. And this isn't just any two things. We want to compare the proportion who satisfy a certain condition between two groups. So what do I mean by that? I mean, that was probably a confusing way to put it. So I'll start with the first example. I pulled these from the presidential election in 2016, and these numbers are from Fox News exit polls. So for the presidential election. Okay, so like all these exit polls, they ask people not only who they voted for, but a whole bunch of demographic questions like how old are you? Do you go to church? What's your income? What's your education level? Stuff like that. One of the questions they ask is, when did you decide your vote? Okay, because some people weren't sure. They only decided at the last minute. Okay, so let me summarize the results in a bit of a table here. So we have the people who say they voted for Clinton and the people who say they voted for Trump. And we're going to separate these into the people who decided in the last week. So in the last week means they were undecided finally 1 week before the election or less. They made up their mind who they were going to vote for. And then there's the other people who had decided before that. So in this poll, there were 263 who voted for Clinton and only decided to vote for Clinton in the last week. And there was 282 who decided in the last week and then went with Trump. And then before that group, there was 2,007 who voted for Clinton and 1,884 who voted for Trump. So the question is, is there a difference in the proportion who voted for Trump between the in the last week group and the before that group? So basically, if you know someone decided in the last week, does that sort of mean that they were more likely to end up voting for Trump? Just looking at the raw numbers from our sample, in the last week group, more people voted for Trump than Clinton, and in the before that group, more people voted for Clinton than Trump. So it seems like if people decided later on, they're more likely to vote for Trump. But that's just in our sample. Remember, all of this stuff could be down to luck. This is a pretty big sample. It has like over 4,000 people in it. That's pretty big. So probably it's true, but those numbers are pretty close together. Like Trump has a slight edge in the last week group, and Clinton has a slight edge in the before that group. There's not that much difference. So how do we know if the in the last week group is more likely to be Trump voters if we extend our results from the sample up to the whole population? How confident are we that they're bigger? Okay, so really what we want to do is compare the proportion in the last week group. Here, I don't feel like calling it the in the last week group, so we'll call this one group 1 and this one group 2. So the proportion who voted for Trump in group 1 to the proportion who voted for Trump in, oops, I didn't write Trump here, Trump in group 2. Okay, so the proportion who voted for Trump in group 1, we're going to call that P1. Okay, so P sub 1. And the proportion who voted for Trump in group 2 is going to be P sub 2. So these are the two proportions that we're talking about. When I say two proportions up here in the top, these are the two proportions we talk about. So we have sort of two groups, and we're sort of like comparing the results in both the groups. You know, like, let's say we wanted to know who's more likely to live in on-campus housing in their senior year, the people who are from in-state or the people who are from out-of-state at Shippensburg. Okay, so we're sort of asking the same question for two groups that are similar but separate, right? So like a common thing would be comparing like males and females, like who's more likely to do something, like the males or the females. So that's what we're talking about with two proportions. There's also another common situation where two proportions come up, and that's in sort of medicine, drug tests. Like, so one group is the group that takes the drug that we're testing, and the other group doesn't get the drug. You know, maybe they get a placebo, so it's like a fake drug, or maybe they get a different drug, and we want to compare the two drugs. But basically, like, the two groups somehow get different treatments, and we want to compare their outcomes. So, you know, who did better, group 1 or group 2? Or is there even a difference? Maybe there's no difference. They did equally well. Okay, so that's the setup. We want to compare the proportion who voted for Trump in group 1 to the proportion who voted for Trump in group 2. So we can find those numbers for our sample. So what is the proportion who voted for Trump in our sample? So P sub 1, and then let's put a little hat on that because it's a sample proportion. Where are my hats? Bring up my accent, put a little hat on. My word is so slow. Okay, there's my hat. Okay, so the proportion who voted for Trump in group 1. So how many people are in group 1? There's 263 plus 282. And the ones who voted for Trump is 282. So this is, the denominator is the total in group 1, and the numerator is the ones who voted for Trump in group 1. So this proportion comes out to 0.5174. Okay, so a little over half of group 1 voted for Trump in our sample, right? And what about group 2? Get my little hat here, P sub 2. Okay. So the total number in group 2 is 1884 plus 2007, and the ones who voted in Trump was 1884. So our proportion in group 2 is 4842. Okay, so group 1, the proportion who voted for Trump is bigger than the proportion in group 2. Quite a bit bigger, like that's more than 3%. But is that a statistically significant difference? Now I'm guessing that it is because 4,000 is a pretty big sample. You know, once you get into the thousands, like numbers have to be pretty close for it not to be a significant difference. But we don't know until we find a confidence interval or run a hypothesis test to get a p-value. So what we actually run our confidence interval and our hypothesis test on, so is the difference between these two numbers. So we can do a confidence interval for the difference P1 minus P2. So you can see that in our sample, the difference is about 3%. But since there's randomness, the real number is not likely to be exactly 3, whatever that is, 3.3%. Could be a little higher, could be a little lower. How much higher or lower? Well, that's why we're doing a confidence interval. Okay, so we're going to have Minitab run the confidence interval. Before I end this video and flip over to Minitab, I want to say that we do have a formula for the standard deviation. Because how much higher or lower it goes, that depends on the standard deviation. You know, basically you take a standard deviation, you multiply it by 1.96 if you want to find a 95% confidence interval, you multiply it by 2.576 if you want to find a 99% confidence interval. How do you find the standard deviation? Well, we have a formula for it. And it looks a lot like the formula we had for standard deviation when it was one proportion, except now there's two proportions to worry about. So let me just select this so that I can copy and paste it. So we have P1 hat times 1 minus P1 hat over N1, which is the number in group 1. And then we have to do the same thing for P2, and they get added together. 1 minus over N2, and these need to be 2's. Okay. So basically you take the old formula for the standard deviation that you use to find confidence intervals that we had in the previous chapter, but you do it for both of your groups and you add them up and they're added together under the square root. Okay, now actually there's two different versions of standard deviation. One that looks just like that, and then another that looks similar. Except there's just a P there. Okay. Okay, so what's the difference between these? Well, here, this is the group in the proportion in group 1 that voted for Trump. This is the proportion in group 2 that voted for Trump. P hat is the proportion in our entire poll that voted for Trump, and you use that in both of these terms. So you end up with similar numbers for these, but they're slightly different. So this one is called pooled, because the two groups are pooled together to form this P hat, and that's what you use in your computation. And this one, I think this one is just not pooled. There's probably a better term for that, but I just remember that one is pooled and the other isn't. So I am going to be using this one most of the time, but actually our book tends to use this one. So if you ever get answers that look slightly different than the book, it's probably because they used pooled and not pooled, and you're actually fine. Your method is okay. All right, so I'm going to end this video here, and then we're going to find our confidence interval over in Minitab.